Hello, this is Scholar Strife doing some math today in Algebra 2. We're going to evaluate trig functions of any angle. So let theta be an angle in a standard position, and let x comma y be the point where the terminal side of theta intersects the circle. The standard circle, x squared plus y squared equals r squared. We then can define the trigonometric functions as follows. So sine is y over r. So looking at this blue line here, sine is y over r, cosine is x over r, tangent is y over x. So think of it this way. Here is our angle in here. The y coordinate is our opposite side, our x coordinate is our adjacent side, and we have our hypotenuse. So sine being opposite over hypotenuse, that's y over r. Cosine being adjacent over hypotenuse, x over r. And tangent being opposite over adjacent, y over x. Cosecant is just sine upside down or flipped. Secant is cosine flipped. And cotangent is a reciprocal of tangent. Example 1. Let -4, 3 be a point on the terminal side of an angle in standard position. Evaluate the 6 trigonometric functions of theta. Okay. So sine of theta is, once again, y over r. So -4 or +3 over the radius. So we don't know what the radius is. So before we do our 6 trig functions, we need to find the radius. So if we're looking at the right triangle again, so here's that right triangle that we made. Here's the right angle. We know that this is -4. This is 3. And the radius is a squared plus b squared equals c squared. So 3 squared plus 4 squared equals c squared. 9 plus 16 is c squared. So c squared equals 25. So c is 5. So sine is 3 over 5. Cosine is the x value, -4 over 5. Tangent is, these are all of theta. Cosine of theta, tangent of theta is negative, or opposite over adjacent, so 3 over -4. Cosecant is sine flipped. Secant is cosine flipped. And cotangent is tangent flipped. And we're done. Unit circle is the circle x squared plus y squared equals r squared, or 1, with a center at the origin, which is 0, 0, and a radius of 1. It's called the unit circle. So because the hypotenuse of the unit circle is 1, that makes every point around the circle so that the x-coordinate is equal to cosine of theta, and the y-coordinate is equal to sine of theta. On the unit circle to the right, please label the points that intersect the x-axis and the y-axis. This would be 0, comma 0. Over here at this point is cosine and sine of theta. Here is cosine of theta, comma 0. So once again, sine of theta would just be y, and cosine of theta would be x. Y, x. Y, x. A quadrantal angle is an angle in standard position whose terminal side lies on an x-axis. So 0 degrees is at 1, comma 0, right here. 90 degrees is at 0, comma 1. 180 is at negative 1, comma 0. And 270 is at 0, comma negative 1. Draw the unit circle and use it to evaluate the 6 trig functions of each angle. So 270 would be, that fourth picture up there. Let's say we're on the unit circle. So 270 is like this. So sine of theta, so this is at negative, or 0, comma negative 1. So sine of theta would be your y value, which is negative 1. Cosine would be your x value, which would be 0. Tangent would be sine over cosine, which is undefined, because that would be negative 1 over 0, cannot divide by 0. Cosecant would just be negative 1. Secant would be 0. And then cotangent would be also 0, because that's 0 over negative 1. 540 would be the same as 540 minus 360 would be the same as 180 degrees. So that looks like this. So we're at negative 1, comma 0. So my sine is my x-coordinate, which is sine is my y-coordinate, which is 0. Cosine would be my x-coordinate, which is negative 1. Tangent would be 0 this time. Cosecant would be 0. Secant would be still negative 1. And cotangent this time would be undefined. A reference angle is an acute angle formed by the terminal side of an angle and the x-axis. So if it's in quadrant 1, your degrees and radians are the same. So that would be this first picture here, quadrant 1, quadrant 2, and then we have quadrant 3, and then we have quadrant 4. So this would be pi minus whatever your radians are. This would be your radians minus pi. And this would be 2 pi minus your radians. Sketch each angle theta, then find the reference angle. 7 pi over 4. So if you don't remember, we can change this into degrees by multiplying by pi over, or 180 over pi. Pi cancels, and we're left with 7 times 180 divided by 4, which equals 315 degrees. 315 degrees looks like this. Our reference angle would be this guy here, which would be 360 minus 315, which is 45 degrees. Negative 130. So here's negative 90. Negative 130 is around here. In order to find our reference angle, we're just going to take 180 minus 130, which is 50 degrees. So this would be my 50. So use a reference angle to evaluate cosine of negative 225 degrees. All right. So negative 225 degrees. Let's do a quick sketch. So we're going back. Here's 90, 180, and we're down here. So we're somewhere like that. The reference angle is right here. The blue. Okay. We know the blue there. So that would be 1. So we take 225 minus 180. And we would find out that this is a 45-degree angle. So if you remember from our unit circle, let's see if I can draw that. So at this spot on the unit circle, this is pi over 4 pi over 4 over here, this would be negative pi over 4 negative pi over 4 pi over 4. Oops, I meant not pi over 4. These are pi over 2, pi over 2. And this would be negative pi over 2, pi over 2. Cosine would deal with the x value, so this would be negative pi over 2. So cosine of negative 225 is negative pi over 2. Cotangent of 10 pi over 3. So remember 10 pi over 3. So pi over 3 is 30 degrees. So 10 pi over 3 is 10 times 30, which is 300 degrees. So 300 degrees is around here. So we're doing that. So cotangent, remember, is opposite is adjacent over opposite. Okay, so I'm looking for cotangent is adjacent, which is x over y. And if we look at our unit circle,